Hello students, welcome back to the class, and today also we are going to discuss some questions on current electricity only. Okay, let us discuss. Here we have the questions. This is our first question. In the galvanometer shows no deflection. What is the resistance of X? Resistance of X he is asking. So according to the Wheatstone bridge, 10 by 40 is equal to 7 divided by X, right? According to the Wheatstone. Then what is the value of X here? So that which gives X is equal to 28 ohm, right? X is equal to 28. So that our option is fourth option. Next question. Okay. The resistance between A and B in the circuit shows. The resistance between A and B in the circuit shows in figure. Circuit shows in figure. Resistance between A and B. So between A and B, like this, the circuit he has given here. He has given, and here this 8 ohm, 4 ohm, they are in parallel, and remaining some arrangement also he has given. So these two are in series, and that resultant of these two will be parallel to this 6 ohm. So let us see what will be the resistance. Okay, see here the equivalent of this figure I am going to draw here. So equivalent of this figure, that 4 ohm remains as it is, and say this is point A, and here see this 8 ohm are parallel, and that is also parallel with this 4 ohm. So that by simplifying that new resistance, I will write that new resistance will be 4 ohm. Just to apply the parallel formula, right? I hope no need to do that parallel formula. Just to apply the parallel formula to this section, and you will get 4 ohm, right? And these two are in series, right? So this remaining 6 ohm I will keep here as it is, 6 ohm, and that will be 8 ohm and 4 ohm are in series. So series connection it become 12. Again these two are in parallel. So sum of those two, again we will get, this is our final circuit after simplified. This is 4 ohm, this is 4, this become 2 ohm. It is actually, it is not 4 ohm, this become 2 ohm. Just to apply the formula to this section, parallel formula, you will get 2 ohm. So this is 2 ohm I have written, and this will become 4 ohm, right? This is our simplified circuit. So then A to B, these all resistance are in series. So that total resistance is equal to 4 plus 4 plus 2, that is equal to 10 ohm, right? Between A and B, 10 ohm is the resistance. Okay, next. Okay, the current I in the circuit, shown in figure. The current I in the circuit shown in the figure. So some options he has given. Current I here he has mentioned, and here 30 ohm and 30 ohm are in series. So that becomes 60 ohm. That 60 ohm resistance will parallel with this 30 ohm. So that I will write the equivalent resistance is given by the equivalent resistance is given by 1 divided by R is equal to 1 divided by 60. 1 divided by 60 plus 1 divided by 30. Say these two are in series, that becomes 60. That 60 ohm will parallel with this 30 ohm. So that I have written in parallel. So equivalent resistance of that parallel combination 1 by 60 plus 1 by 30, just to simplify. By simplifying, R is equal to 20 ohm you will get here. 20 ohm. Therefore, our aim is to find current only. So, we know that current I is equal to, and 2 volt he has given, 2 volt divided by 20 ohm. So, that 1 by 10 ampere current we will get here. Right? Okay, fine. Next one. See, the internal resistance of the cell shown in figure is negligible on closing key K. So, just to go through this figure. On closing the key, the ammeter reading changes from 0.25 to 5 by 12 ampere. 5 by 12 ampere. Ammeter reading changes from 0.25 to 0.512 on closing the key. On closing the key. Just to remember. Okay. First, initially, our current is. Initially, it is 0.25, right? 0.25 ammeter it is. Then what will be the terminal voltage? The terminal voltage V is equal to, voltage is equal to, that I will write, say, in figure resistance he has given 10 ohm, that 10 into 0.25. So terminal voltage we got here, that is 2.5 volt. So initial current we have here and terminal voltage we have. Now when key is closed, I becomes, when key is closed, see, while on closing the key, current fall from 0.25 to 5 by 12. Okay, then on closing the key, then I is equal to how much it is? 5 by 12, right? 5 by 12 ampere. So that then effective resistance I am going to find here. If R2 is the effective resistance, then it is given by, here I will write 1 by R2 is equal to 1 by R1 plus 1 divided by R. Effective resistance I am going to find here, right? The internal resistance, once you observe the question, the internal resistance of the cell as shown in the figure, right, is negligible. On closing the key, current falling from 0.25 to 0.25 to 5 by 12. Then R1 is equal to 10 ohm he has given, 15 ohm he has given, and C option, the power drawn from the cell decreases, and D option also something he has given, current through R decreases by 40% he has given. So let us say what will be the effective resistance. If R2 is the effective resistance, then I am doing here 1 by R2 is equal to 1 by R1, this, and this is our R. Then what is the effective resistance of these two resistors? These two resistors are in parallel, so I write it like this, right? Okay. Then R2 is equal to formula becomes R1 R divided by R1 plus R, right? Simple it is. And here we know the value of I, and V also. With the help of V value and I value, just to simplify using this formula, using this value of R2, just to simplify, by simplifying R1 is equal to, just I am writing after simplified, R1 is equal to 15 ohm and R2 is equal to, you will get 16 ohm, right? This is R2, this is R1, right? So just to use these two values, V is equal to 2.5 we have, I is equal to 5 by 12, right? So just to use this relation or this relation, by using this R1 and R2 we will get here. So R1 is equal to 15 ohm, R2 is equal to 16 ohm. So that the power drawn, see, power drawn V square by R. Power drawn V square by R increases since the total resistance what it is decreases. Total resistance decreases, so that our option is second option. Total resistance decreases, so R1 is equal to 15 ohm. I will choose, right? 15 ohm, right? Okay, this is the method. I hope you are getting this. This is initial current and this is terminal voltage we have taken through this, and when the key is closed, current fall from 0.25 to 5/12. So when the key is closed, I is equal to 5/12. This is initial current, it is, right? Okay. Effective resistance of this R1 and this R is that I have written here. Using this formula, use this formula, and with the help of this value of V and I, just to simplify, R1 is equal to R2 is equal to, you will get. So power drawn V square by R, since it is total resistance decreases here, so R1 is equal to 15 ohm. Okay, next. See, two equal resistance R1 is equal to R2 is equal to R connected with 30 ohm. Okay, resistor and a battery of terminal voltage V. The current in the two branches are 2.25 and 1.5 as shown in the figure. Then what is the resistance? Right? Okay. Say, using Kirchhoff current law through R2. That I will write using KCL through R2 is equal to 2.25. See, I hope you know KCL, right? That is 2.25 minus 1.5, it becomes 0.75 ampere. Okay. Also, since here R2 is parallel to 30 ohm. So R2 must be 60 ohm here. 60 ohm. R2 must be 60 ohm. Since only half of the current will, only say here resistance R2 must be 60 ohm, and here you remember only half of the current will flow through R2 as compared to this 30 ohm. Whatever the amount of current flowing through this 30, under that only half of the current will flow through this R2 because it is 60 it is. So that the total resistance in the circuit, total resistance because he has given this R1 is equal to R2 is equal to R he has given, right? Okay. See here, total resistance in the circuit becomes 60 plus this 20 is equal to 80 ohm. This is our total resistance. And what is the potential drop? Here? Okay, potential drop across the battery is V is equal to IR. That is equal to 2.25 into 80. So that is equal to 180 it is. Hence our option is fourth option it is, right? Potential difference we got here, that is 180 potential, right? Next, Okay, next question. Question number 26. Say, which of the following statement is correct about the circuit shown in the figure? This figure he has given. So, which of the following statement is correct about the circuit as shown in the figure? Where 1 ohm and 0.5 ohm are the internal resistance. 1 ohm and 0.5 ohm are the internal resistance of the 6 volt and 12 volt batteries respectively. Internal resistance 1 ohm and 0.5 ohm are the internal resistance of 6 volt and 12 volt batteries respectively. Okay, which of the following statement is correct for this given figure? Right? Okay. See, in given figure 1 ohm internal resistance he has given it. Here is 0.5, 6 volt, 12 volt and resistance 4 ohm, and here 0.5 ohm he has mentioned, and here he has connected this SR term to grounded. Okay, let us see. Say total, first I will define total resistance. Total resistance in the circuit is equal to, that I will write from the figure itself, it is 4 plus 1 plus 0.5 plus 0.5, right? Okay, that is equal to 6 ohm. Okay, 6 ohm we got. The net voltage in the circuit, net voltage, net V, net voltage is equal to 6 volt. I will take 6 volt. See, because this is 12, this is here it is 12 and here it is 6 he has given, so net what it becomes, net we will get here 6 volt. Then what will be the current? Therefore current I is equal to 6 by 6 is equal to 1 ampere. 1 ampere in the anti-clockwise direction. Now I am going to define. I hope you got this. Voltage also we have here 6 and resistance also we have 6, so that current 6 by 6 equal to 1 ampere. 1 ampere. Okay, see from the figure, in anti-clockwise direction, in anti-clockwise direction, like this, in anti-clockwise direction, potential, see actually what are the options he has given? Potential at P he has given, potential at Q he has given, and if voltmeter is connected across the 6 volt battery, it will read 7 volt. If voltmeter is connected across the 6 volt battery, it will read 5 volt. Some options he has given. So here I want to know potential across P and Q, so that I come to know that which statement will correct here. So that first I will write potential P to R. I will define P to R to this term, P to R. Potential is equal to, say, however, current is 1 into resistance 4 ohm, that is equal to 4 volt. Next, since R is connected here, since this R is connected to ground, since VR is equal to 0, because R is grounded, VR is equal to 0. Hence, if VR is equal to 0, then VP, potential at P is equal to 4 volt. See, concentrate here. See, potential P to R, 4 volt we got. However, our 4 volt is connected to ground, so that VR becomes 0, potential at R becomes 0, so that potential at P remains 4 volt. It is 4 volt we got. Okay, now see here. Similarly, to this term I will define Q to S, potential Q to S. Again, Again here resistance is 0.5 and current is 1, that is equal to 0.5 volt, right? So 0.5 volt we got. See here, this is anti-clockwise direction, right? So S is at higher potential as compared to Q. S is at higher potential than Q. So therefore potential at Q is equal to minus 0.5 volt we will get here, right? So current being forced into the 6 volt, current being forced into the 6 volt battery in the opposite direction. Current being forced into 6 volt battery, 6 volt battery. So potential at 6 is equal to opposite V plus E plus IR formula. So use this formula and substitute the values. 7 volt we will get here, 7 volt, right? So that our option is third option. If voltmeter is connected across the 6 volt, if voltmeter is connected across the 6 volt battery, it will read 7 volt. It will read 7 volt, right? Okay, I hope you are getting this. Next. Okay. In the circuit shown in figure, this figure, here we have the circuit. Okay. In this circuit, some options he has given. Current through LP is 0.5, value of R1 he has given, value of R is equal to 14. So potential difference across R he has given 49. So we have to calculate current through LP and value of R1 also we have to calculate. Then how much we will get, then which option is correct we have to identify in the given figure, right? Okay. See, just to observe this figure, here potential difference across MP, is equal to potential difference across NP, and that is equal to potential difference across ON. See, potential difference across these three resistors are equal here. Potential difference across MP is equal to NP is equal to potential difference across NO from the figure. So potential difference across MP is equal to potential difference across NP is equal to potential difference across ON from the figure. Right? Okay. Here I want to know first option what he has given, current he has given. Okay. See here I want to know current through NP. Current through NP. So however potential of all the three are equal here. So I will compare product of IR, this is equal to this. NP is equal to ON, I will compare. So in NP, I will get INP, current through NP. See, current into resistor, how much he has given? 10 ohm he has given in NP. Resistor is 10. So I into R is equal to, potential I am comparing, potential of this I into R, that is equal to potential of ON again, current is 1 ampere he has given in the figure, 1 into resistance 20. So here INP is equal to 2 ampere you will get. 2 ampere. Okay, I hope you are understanding this. Now across MP I will check here. Across MP across MP. Okay, across MP, say potential across MP 0.5 is what current, and resistance is R1. 0.5 is the current and resistance is R1. Okay, that is equal to 20. That is equal to 20. Okay, so R1 is equal to, here we will get 40 ohm, right? Here R1 is equal to 40 ohm. However, potential of all are equal, no? So just I have compared here, that's all. Just I have compared. Okay, next, see here, that total current I is equal to 2 plus 0.5 plus 1.0. 1 he has given here. Okay, so just to go through the figure, so total it is 3.5 ampere. So finally we have the formula here to find the value of R. See, R is equal, see, I is equal to E divided by R1 plus R. R1 plus R. So with the help of this formula, just to find the value of R, so R is equal to 14 ohm we will get here. All the values we have here. All the values we have. See, E is equal to 69 volt here. 69 volt he has given, and here we got R1 also. So just to calculate here, right? So by using this formula, we will get R is equal to 14 ohm. So that our option is that is third option, value of R. Okay, remaining you check. First option, current through NP is 0.5 he has given. Current through NP, how much we got here? Current through NP 2 ohm. So this option is wrong. So the value of R1 is equal to 30 ohm he has given. R1 is equal to how much we got? 40 we got. So this option also is wrong. First also wrong, second also wrong. And with the help of this, say current I have find out here, I is equal to. So finally I got R is equal to 14. So that our option is third option here, right? So just to go through the figure and you will get it is R value is 14 ohm. C option he has given, that is correct because we got that. Okay. Next, 3 resistance of 4 ohm each are connected as shown in the figure. This is figure. If the point D divides the resistance into two equal halves, point D, if we divide point D, this out of 4 ohm it becomes 2 plus 2, right? The resistance between the points A and D, the resistance between the points A and D, say after dividing this figure becomes like this. This figure becomes like this. Just I will draw here. Say this is resistance like this. After dividing, okay, this is 4, this is 2, and here 4, again this is 2, and this point is A here, this point is C, and this point is B, and this point is D. Okay, just we have splitted this D point into 2 equal parts so that it becomes 2 plus 2 it is, so that this is our new simplified figure, right? So by this simplified figure, what is our aim? Our aim is to find resistance only, it is right? So that 1 by r is equal to 1 by 6 plus 1 by 6, right? Okay, that is equal to 1 by 3. 1 by r is equal to 1 by 3. So r is equal to 3 we got, right? This is next. Okay, see the range of voltmeter is 5 volt and its resistance is 5000 ampere. See, the range of a voltmeter is 5 volt, maximum range is 5 volt and its resistance is 5000 ohm. See, in bracket he has given 4900 ohm connected in series with the coil of resistance 10 ohm. 4900 ohm connected in series with the coil of a resistance 100 ohm. See, that coil of a coil. See, this 4900 ohm resistance is connected in series with the coil of resistance 10 ohm. That you remember. What additional resistance should be connected in series with it? What additional resistance should be connected in series with it so that its range should be doubled? ಇದು ರೇಂಜ್ ಡಬಲ್ ಆಗಬೇಕ್ರಿ. 5 ವೋಲ್ಟ್ ಇದ್ದಿದ್ದು 10 ವೋಲ್ಟ್ ಆಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಕ್ಸ್ಟ್ರಾ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು, ಎಡಿಷನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್? ದಟ್ ಈಸ್ ಅವರ್ ಕ್ವಶನ್. ಓಕೆ, see if I is our maximum current, if I is maximum current, if I is maximum current can flow through the coil, let us assume. So that 100 I and that plus 4900 I, that is equal to 5 volt. 5 volt. So I is equal to how much we got here? 1 divided by 1000 ampere. This is our I value. Okay, then what is the resistance is required? If R is the resistance is required, if R is the resistance is required, then now I will write, by connecting the value of R, additional R, then total resistance becomes R dash. Total resistance becomes R dash. So that should be like this. R dash is equal to that our circuit resistance plus 4900 ohm. It becomes like this. Then what is the value of R? That I want to know here. Okay. So here I am writing with that coil 100 I in that coil. 100 I. 100 is the resistance of that coil. Right, in that coil this I is the maximum current can flow through that 100 ohm resistance coil, right? So if R is the required resistance, then 100 I plus R dash I, I hope you are understanding this. R dash I is equal to 10. Now this time double I am writing. Previous it was 5 volt for this given data, right? See, resistance into current, right? So here also resistance into current, and here now this time I want double. So for that R dash is our new resistance by connecting the value of new additional resistance. Okay, what is that? Since R dash is equal to R plus, see, okay, anyhow here we will get R dash. Already we know the value of I, no? So with the help of this value of I, R dash is equal to, directly I will write here, R dash is equal to 9900 ohm we will get here. This is what it is, R dash. Then what is the value of R? R is what? R is our required resistance. So now I will define R dash is equal to R plus 4900. Then R dash we got here, R dash we got already, so that R becomes 5000 ohm. I hope you are understanding this, right? Okay, this is our solution. Our option is first one. Next. Okay, next question here. A 100-watt bulb and 200-watt bulb are designed to operate at 110 and 220 volt respectively. The ratio of their resistance R1 by R2 is equal to his question. Okay, anyhow, before that, see, here we have the formula P is equal to V square by R. P is equal to, because watt he has given, right? I can use this. So already power means watt of the bulb he has given, power of the bulb. So power of the bulb P1 by P2 I will do here to find the value of R1 by R2. P1 by P2 is equal to, with the help of the given data, that is equal to 1 by 2 we got here, right? Okay, now P is equal to V square by R, we know this. Therefore P1 by P2 is equal to V1 square by, same using this relation, V1 square by R1 into R2 divided by V2 square, right? So just to substitute the values, and you will get R2 divided by 4R1. Directly I have written here P1 by P2 is equal to R2 divided by 4R1. Just to substitute the values he has given here, right? Values he has given, V1 and V2 value we have. So just to use that values, V1 and V2 values, so that R2 by 4R1 we will get here. And what is the value of P1 by P2? Already P1 by P2 is equal to 1 by 2 we have here. So that but P1 by P2 is equal to 1 by 2. If P1 by P2 is equal to 1 by 2, then therefore R1 by R2 it becomes 1 by 2 only. Hence our option is second option, right? Watt means power he has given here. So power formula we have used here. Watt means power, it is power 100 and 200 he has given respectively, 110 volt and 220 volt. Under that voltage they have worked, so that this formula we have used. P is equal to V square by R. With the help of this R1 and R2 we can calculate. Okay, next. Okay, see here, a constant voltage is applied across a uniform wire. Constant voltage, for example, this is the wire. Constant voltage is applied a uniform wire which produces some amount of heat. Heat is denoted by H, which produces some amount of heat in the wire. If a second wire of the same material but length twice, let us assume this is, if it is L, this is 2L. Same, say if a second wire of the same material is same, length twice that of the first wire is used, the heat produced in the second wire will the same as in the first wire if the area of cross section of the second wire is. Okay, say however already he has given same heat is produced in second wire also, same amount of heat is produced, because the resistivity, because same material, resistivity of both the wire is same, so same amount of heat will produced here. But if the what it is, area of cross section is doubled, then it is possible for this given case. It is how it is, we know heat produced V square by R power, heat produced V square by R, that is equal to V square divided by V square A divided by, I can write this V square A divided by rho into L. It is right. How we have written here? Formula I have written this formula, right? Formula I have written, so that here rho is the what? Resistivity. Rho is the resistivity. Therefore, heat produced will be same in second wire if the length is doubled. If the length is if the length is doubled, same amount of heat is produced. If area of cross section is doubled, if area of cross section is doubled, so that our option is that is increased by the factor 2. Area of cross section increased by the factor 2. So C option, right? Okay, next, last question. Okay, see here. 3 unequal resistance connected in parallel are equivalent to a single resistance of 1 ohm. Equivalent to a single resistance of 1 ohm if two resistors are in the ratio of 1:2, and if no resistance is fractional, the largest of three resistance is okay. See, first what he has given, 3, and let us consider 3 unequal resistance, x, 2x and y are the 3 resistors. See, then x and 2x are connected in parallel. Already he has given, no? Say 3 unequal resistors connected in parallel are equivalent to a single resistance 1 ohm. So x and 2x are in parallel equivalent to single resistance. So that I can write equivalent to single resistance means just to apply the parallel formula for this x and 2x. So 1 by R1 is equal to 1 by x plus 1 by 2x. By simplifying that, R1 is equal to 2 divided by 3x. This is R1 value we got. Parallel formula we have applied for these two resistors, right? Okay, this is equivalent to, this resistance is equivalent to a single resistance. So also I can write, say this resistance, that obtained resistance 1 by R1 plus 1 by y parallel, that is equal to 1 ohm resistance, right? Okay, so use that value of R1. This step I can write 3 divided by 2x plus 1 divided by y is equal to 1. Okay, minimum value of x here, just I am going to observe here. Minimum, see, for this given condition satisfies, for the value of x is minimum value of x which satisfies the given condition x is equal to 3. Hence y is equal to 2. 3 resistors are therefore 2, 3 and it becomes 6. So our option is 6 ohm it is, right? Okay, next. Say a copper wire of length 50 centimeter and area of cross section 10 to the power minus 6 meter square carries a current of 0.5 ampere. If the resistivity of copper is 1.8 into 10 to the power minus 8 ohm meter, the electric field across the wire. So we know that electric field E is equal to V by I. Electric field V is equal to V by I, and we know that at the same time V is equal to IR, right? So just to write the resistance formula, and rho L it is rho L divided by A I can write. So just to use this value of V here, right? I hope you got this. Just to use that. So electric field formula become electric field I rho divided by A. By substituting the value of V here, we will get this. And now substitute the values. 0.5 into 1.8 into 10 to the power minus 8 divided by area 10 to the power minus 6. By simplifying, you will get D option. Okay, it is very simple. I hope you are understanding this, right? Okay. Next, this is the last question here. Okay. See here, what is the current flowing through the galvanometer in the circuit as shown in the figure? Current flowing. Our aim is to find current. So to find the current, we should know the value of V as well as R. So by using Ohm's law we can find, but the resistance he has given here like this. These two are in parallel here. So just to apply the formula, and this resultant resistance will be series with this resistance, right? So total resistance I will define. Total resistance is equal to 80, this 80 plus series to this, and this is in parallel now. So parallel formula I will write. So 80 into 80 divided by 80 plus 80, 160. Reciprocal I have taken already it is. So just to simplify it, by simplifying 120 ohm you will get. Therefore current in the circuit. Therefore our aim is to find current only now. So current I is equal to 2.4. Already he has given 2.4 divided by 120, that is equal to 0.02 ampere. This is our solution, right? 0.02. Okay, this is the question. I hope you are understanding this. Once you observe the figure, right? See what we have done here. Total resistance we have defined. This resistance will be series with this parallel. These two are parallel. Just to simplify it, that term I have written here. This is parallel, and that will be series with this 80 ohm, right? So we got 120, right? So that 0.02 ampere we got. So current through the galvanometer, finally it is 0.01. It is current through the galvanometer 0.01, right? So this is our solution here. Okay, in the next class we'll start with moving charges and magnetism. Okay, thank you.